To do another activity with infrared and investigate infrared's role in TV remotes. And you see the image, but you wouldn't see the lights with your eyes. You need a special camera to be able to produce an image like that, to see the infrared. But first, let's look at what infrared is. It's heat energy. Anything with a temperature above 0 Kelvin emits infrared radiation. You do. Even an iceberg or dry ice at minus 78 degrees Celsius and liquid helium at minus 268 degrees Celsius, which would then solidify at minus 272, which is really close to absolute zero at minus 273 and a bit degrees Celsius. Nothing can be below that temperature because all atomic motion stops. What we do know about infrared is that it's made up of waves. So it's going to be similar to visible light. But you can't see infrared with your eyes, but you can feel its warmth, like the heating element in an oven, and actually you see that as red, but that isn't the infrared, that is red light. Infrared has longer wavelengths in the oval on the diagram there, longer wavelengths than visible light, and sunlight is made up of the colours of the rainbow, with red having the longest wavelength. So your heating element is giving out some light as well as the infrared heat. Also, the infrared and indeed the visible light are only part of the electromagnetic spectrum. There are several other regions: ultraviolet, X-ray and gamma with smaller wavelengths, and microwave and radio with larger wavelengths than microwave. And then you can pause the following spectra to actually look at more detail. On this one, you've got the wavelengths in kilometers, centimeters, and going down to 10 to the negative 13 centimeters for gamma rays, and some diagrams there of examples. And a more straightforward ones here, just to remind you that infrared is part of the electromagnetic spectrum. And some more diagrams of items here with those particular wavelengths. And the frequency of waves can be measured in hertz, and 1 hertz is 1 wavelength per second. And infrared isn't a single wavelength, it's a range of them. Here divided into 4 regions, you often find divided into 3. The longest on the left, size of a pinhead, 1 millimeter, 1,000 micrometers, and the shortest 0.7 micrometer, or that's 700 nanometers, the size of a bacterium. And on that bacterium side, with arrowed 0.94, which is one of the infrared frequencies of a TV remote. So you point TV remote and press a button. So many TV remotes emit infrared messages that are received by the television, which is going to respond. And you've got a wavelength, the shortest wavelengths of IR. And we're going to try it out. So what materials do you need for the activity? A TV remote has to be an IR remote for this activity, not one that works on radio frequencies. More about that in a moment. And a digital camera or smartphone that can view those wavelengths of infrared rays and indeed photograph them. And so step 1, check your remote controller is not one that works on radio frequencies. If you can turn on the device, example a TV, with its remote pointed away from the TV, then it's a radio frequency remote. The difference is with an infrared remote, you need to point it directly at the device. So once you know you've got an infrared remote controller, now we have to go on to the camera, and that's what we will do. So first thing is, you're going to communicate with your remote, not with the television, but with the camera, and you're going to look at the little LCD light, what looks like an LED light at the front end of your remote. And you're going to set it up so that your camera is pointed at the working end where that little light is for the infrared source. And what you're going to do is you're going to turn on, press the power button for the device, the television, with it pointing towards the camera lens, and you can look at the screen behind and take a picture of it. Now, if it's a infrared reading camera, you'll actually see a light there. So you can take a picture of that end, the working end of the remote. So, smaller left-hand image, no buttons pressed, no infrared ray visible by the infrared detecting digital camera. And when the TV remote is used, here the on-off button is pressed, the infrared rays can be seen by this digital camera, and some smartphones, my iPhone 12 doesn't, and capture the image with it here. And here's a reminder about the different wavelengths of infrared, but actually the ones that are used in your TV remote are way on the right and bracketed in the near infrared region. Now find out a bit more. Here are some URLs to connect with making waves. You can also go to the QR code and go directly to them. Infrared and rainbows. Well, we know infrared is just outside rainbows, but that's what it's looking at. And some interesting ones about infrared and nature. And you can also do a web search of Smithsonian Learning Lab, go to Discovery and write infrared in the search box, and then choose Learning Lab Collections and select the one that looks like the box on the right there. And once you've researched infrared as much as you want to, go to any other resource that you would like to investigate, because there's so much information there and some wonderful resources. Enjoy.